Hi everyone, welcome to my channel. In this video I'm going to discuss the chapter Semiconductor Electronics. This is going to be the first video in this series. So let's start the video. Now you have heard about conductors and insulators. Okay, conductors, they conduct electricity. Insulators are something which don't conduct electricity. But then what is the purpose of this semiconductors? Why do we need to study about semiconductors? See, suppose you have a circuit with a bulb and this is connected to a source of potential with a key. This is the positive terminal, this is the negative terminal, this is the key, this is the bulb. Now the moment the key is closed, there will be potential difference across the circuit and there will be flow of current. Now if this polarity of this battery is reversed, initially this side is high potential, this side is low potential. Now if the polarity is reversed, so that this side you have negative potential, this side you have positive potential, and again the key is closed, this bulb will glow again. So in the first case, when this side you have high potential, this side low potential, current will flow in clockwise direction. When the polarity of the battery is reversed, the current will flow in anti-clockwise direction. So now this is the conducting wire and this is the bulb. So the current in the conductor flows irrespective of nature of potential difference. Irrespective of nature of potential difference means if this side there is low potential, this side there is high potential, there is a flow of current. If this side there is a low potential, this side there is a high potential, again there is a flow of current. So conductor, the necessary condition for current to flow is that there should be a potential difference. Okay, if there is a potential difference and the circuit is closed, definitely there will be a flow of current. Whereas in calculators, what do we see? The moment you press 0, do all the LEDs glow? No. When you press 1, the display in the calculator is 1. When you press 2, the display in the calculator is 2, and so on. So in calculators we don't use semiconductor, or we don't use conductor, we use semiconductors. Now when you use semiconductors, see, depending upon the nature of the input you will get an output. Depending upon nature of input there will be an output. So in conductors it is just that if there is a difference in potential difference, it is going to conduct. But semiconductors, they don't do this. So they are basically semiconductors. They are devices which with a controlled flow of current. Devices with controlled flow of current, and this flow is dependent on how it is controlled by the maintaining the potential difference. Okay, by maintaining the potential difference. Now basically in this chapter we are going to study few of the electronic devices like oscillator, amplifier, and rectifier. These are the basic devices, basic electronic devices which we will be studying in this chapter. But electronics have wide applications. Okay, electronics have wide applications. They are used in communication systems, like telephone, telegraph, mobile phone, fax. Okay, they are used in entertainment. The TV broadcast, radio broadcast. Okay, the FM channel you hear. Defense, in radar system, guided missile system. Then in the medical field, all the medical devices use is all are based on semiconductor devices. They're based on electronic devices. So these are the applications which you will be studying in higher course of studies, and in class 12 you will be studying about rectifier, amplifier, oscillator. Okay, we will study about these in the future videos which I'll be showing, but this video is just the basic introductory video on semiconductor electronics. Now let us proceed further. So next we will see the classification of materials. Classification of materials. Now materials, based on this classification is based on conductivity. So they are classified in three categories. They are classified in three categories. One is the metals or the conductors. Metals or the conductors, semiconductors, and insulators Okay, now metals, they have low resistivity and high conductivity. Semiconductors, they have in between, means intermediate conductivity and resistivity. And insulators are just the opposite of conductors. So they have, metals and conductors, they have low resistivity. So insulators, they have high resistivity. And very low conductivity. Low conductivity. Okay. Now these semiconductors, they are again of two types. One is the elemental semiconductor. Elemental semiconductor. In this you have this silicon and germanium. Silicon and germanium, these are elemental semiconductors. Then you have organic semiconductors. Organic semiconductors. In this you have anthracene. Okay, there is one more category, that's the inorganic. Inorganic semiconductors. For this example is cadmium sulfide, gallium arsenic, GaAs, gallium arsenic, and the CdS, cadmium sulfide. So this is the classification of materials: metals, semiconductors, insulators. Semiconductors, three types: inorganic, elemental, organic. Okay, now next we will see the classification on the basis of energy bands. So classification on the basis of energy bands. Now before we go into the detail of this classification, we need to understand this, that for a single atom, suppose this for single atom, this is the nucleus with proton and neutron. Now electrons, they are revolving in various orbits. Suppose this is one electron, this is another electron, this is another electron, this is another electron. Okay, so for a single atom, the electrons is orbit dependent. On various orbits you will have different number of electrons. But what happens in solid? See, in solid the atoms are very closely fused. Okay, there is almost no space between the atoms. So these atoms are very close. So it is for this reason the energy level state of electrons overlaps. So in solids, see in here for single atom energy state are different, for this electron different state, for this electron different state, but in solids, since the atoms are very close, the energy state, they overlap. In solids, the energy state of electron overlaps, okay, and they form a continuous variation. These bands, these energy state forms a continuous variation, which is called energy band. So this classification is based on these energy bands. So these energy bands, they are of two types. One is the valence band, another one is the conduction band. Now valence band, this includes energy levels of valence electrons, okay. So includes energy level of valence electrons, okay. And conduction band, it belongs to the energy of those electrons which have energy slightly greater than valence band. So energy band above the valence band is conduction band. So this conduction band lies above the valence band, okay, and the gap between the valence band and the conduction band is called the energy band gap. Energy band gap, it is the gap between valence band and conduction band, valence band and conduction band. Now let us see what kind of possibilities that may exist in this classification of materials in the form of on the basis of energy band. Now this first possibility is, suppose this is the conduction band and this is the valence band, VB for valence band, CB for conduction band. It is quite possible that both are partially filled. Okay, both partially filled, or you can have both the bands overlapping. Suppose this is one band and this is another band. So this is the overlap region, this is the overlapping region, okay. So this band overlaps, okay. In this case, since it overlaps, the band gap, energy band gap, denoted by the symbol Eg, this energy band gap. See, energy gap, it is a gap between valence band and conduction band. Here it overlaps, so the energy band gap is 0. So in both the cases, see, either the conduction band is partially filled or there is overlap. Because of overlapping, electrons are available in the conduction band. In both cases, the material will have low resistance and high conductance, or low resistivity or high conductivity. Such materials are metals, okay. So metals have low resistivity and high conductivity. So these are the two situations they may have, okay. Now second case, when you have the conduction band and you have the valence band. The valence band, you have electrons, okay, but this gap is very large. This band gap is, say, greater than 3 electron volt. So that no electrons are available in the conduction band. So such materials are insulators. So what are insulators? Based on band gap, they have large band gap. Insulators are materials with very large gap between the conduction band and the valence band. Now, third category is the semiconductors. Now, semiconductors are not conductors, so they can't have this kind of situation. What they have? This is the conduction band, and this the valence band. This gap, this small band gap, Insulators have a very large band gap. So here the band gap, energy band gap is less than 3 electron volt. Okay. So this is the classification of materials, solid materials based on energy bands. I hope this concept of classification of material of energy band and classification of metals, conductors and semiconductors on the basis of conductivity and resistivity is clear to you and it is helpful for all of you. Good luck.